This conference will now be recorded.
Hi, everyone. This is Lee Byerly. Welcome to the Satellite Book Club Seminar, Series 119. I'm introducing today on behalf of Brian Gockel from the Office of Observations. And today's presentation is entitled The Geostationary Lightning Mapper, Trends Prior to Tornadoes Associated with Landfalling Tropical Cyclones in the U.S. Our presenter is Gabby Brown. She's a former intern from the Columbia, South Carolina Weather Forecast Office. And the facilitator today, we welcome Jenny Pittman, who is the Science and Operations Officer from the Topeka, Kansas WFO. Just a reminder to the audience that today's session is being recorded. Q&A will be after the presentation, and we encourage you all to, particularly if you're from a forecast office or a regional headquarters, to post your questions in the chat room, and we will field them through there. And please also sign in with your full name to specify who you are in the chat, if possible, and we will continue our discussion from there. We're also looking for future presenters. Please contact the TowerS team, and the training team can also help in creating training materials that may be unavailable. And for that, we can contact Brian Mata for information or questions regarding that. And we appreciate the TowerS team, Kashad Bowman in particular, for helping all the behind the scenes things to run our book club. And at this time, I'll just introduce everyone to Gabby. Gabrielle Brown is a senior undergraduate in atmospheric sciences. She's at Northern Vermont University, formerly Lyndon State College. During her time at Lyndon, Gabby has had the opportunity to participate in several research opportunities, including the Ernest F. Hollings internship, which she conducted at the National Weather Service in Columbia, South Carolina. She also participates in the NBU Lyndon student chapter of the AMS and the NWA as president, and the Climate Consensus Incorporated as a student leader and representative for her school. Gabby, thank you for taking the time today. Welcome.
Thank you so much for that great introduction. All right, I'll just get started then. So as Lee had said, my name is Gabby, and I'm a senior at Northern Vermont University, Lyndon, studying atmospheric sciences, and I'm very excited to be here today to present to everyone. And so as a part of the class of 2021 Ernest F. Hollings Scholarship Program, I had conducted my research with the National Weather Service in Columbia, South Carolina. And so the research we worked on was using geostationary lightning mapper trends prior to tornadoes associated with landfalling tropical cyclones in the United States. And you can forward to the next slide. Great, thank you. So just a outline or an overview of what I'll be going over today. So I'll just be doing some background information on the topic or on the research that I conducted. And I'll also be going over the hypothesis or motivation and why we conducted this research, how I gathered my data and quality controlled it, my methodology, results, and then my conclusions, future work, and acknowledgements. You can forward to the next slide. So just some brief background information. So the Geostationary Lightning Mapper is where we got all of our data for this research. So the Geostationary Lightning Mapper is an instrument on one of the GOES-R series satellites. It detects all forms of lightning, including in-cloud, cloud-to-cloud, and cloud-to-ground lightning. And it does this by observing light emitted by the tops of clouds. And it can do this both during the day and the night. But the GLM is the first operational lightning mapper in geostationary orbit, and it's currently used by forecasters with warning and severe weather situations to reduce false alarms and improve lead times. You can go to the next slide. Thank you. Some further background information. So flash extent density is a product of the GLM that we looked at extensively throughout this research. So flash extent density is the number of flashes that occur within a grid cell over a given period of time. And the period of time that we looked at throughout this research was over the course of 1 minute. Now, another product that we looked at throughout this research was the minimum flash area, and this product reports minimum size of any GLM flash spatially with each 2 by 2 kilometer grid cell during a specified time period. And once again, that time period is going to be over the course of 1 minute. And so we did not look at, we're not going to review minimum flash area, this product, as much throughout the presentation as we will flash extent density, and I'll explain a little bit as to why that is the case a little bit further in the presentation. But right now we can move on to the next slide. Thank you. So for our hypothesis, so the GLM has been investigated in previous research and used in current operational strategies when it comes to warning in severe weather situations, but it hasn't yet been looked at with the challenge of warning on tornadoes that spawn from landfalling tropical systems. And so tornadoes that spawn from these tropical systems are more difficult to identify using current radar interrogation techniques due to the fact that they're shorter lived, they have weaker signatures, and smaller vertical structure that makes them difficult to identify at significant distances from the location of each individual 88D radar location. But overall, this work seeks to investigate if the GLM can add lead time by aiding forecasters to more quickly identify which cells within tropical systems have the likelihood of producing tornadoes. Next slide, please. Great. So for how we gathered our data. So all United States landfalling tropical systems from 2019 to 2021 were identified, and these were identified using the National Hurricane Center's Atlantic Tropical Cyclone Archive. So we had identified 21 tropical systems that made landfall or impacted the US. And by impacted, I mean we included days where the center of the cyclone may have been offshore, but had rain bands affecting land. But going further into that, we had looked at tornadoes associated with tropical systems, and these were identified by inputting all the dates that land was impacted by these tropical systems. And we inputted those into the National Center for Environmental Information's storm event database, and we had identified 265 tornadoes that were spawned from these tropical systems. Next slide, please. Thank you. So going about gathering our data and quality controlling it further, so we used archived GLM data, and we viewed this data through NOAA's Weather and Climate Toolkit. So both products, the GLM flash extent density and minimum flash area, were collected for each minute 30 minutes prior to every tornado touchdown that had occurred. So every minute of the 30 minutes prior to all 265 tornadoes, we gathered data for those. And then we also had looked at for tornadoes that had it was a little bit more difficult to identify which lightning was associated or which lightning clusters were associated with the tornado itself. We had used GR2 Analyst, which you can see in the bottom right-hand corner. This was used to compare radar to view the lightning associated with the tornado and make it a little less difficult to kind of view which lightning, was associated with that tornado. Next slide. Thank you. So going further into our methodology. So we used Microsoft Excel. So the GLM data was inputted into two separate spreadsheets. We separated it by flash extent density and minimum flash area. And so analysis was done by averaging each minute's data 30 minutes prior to the tornado touchdown in a variety of ways. So this first includes averaging it with all tornadoes involved for each minute. We then looked at individual named tropical cyclones. We did analysis by time of day these tornadoes occurred, the location of these tornadoes by regional and latitude and longitude in 10-degree bins. And then lastly, we looked at the status of the tropical system at the time of the tornado. But we average data was displayed on time series plots to better view the trends that we saw. And so further analysis, we had also done value frequency and looked at a few specific tornado case analysis for both flash extent density and minimum flash area. Next, please. Thank you. And so this was just a map showing all of the tornado touchdowns, of all 265 tornadoes we looked at. Next slide. So getting into the results. So the first two plots that you see here is an average of flash extent density and minimum flash area of all 265 tornadoes of all 21 tropical systems that were analyzed. And so overall, we found that flash extent density increased as you got closer to tornado touchdown. And then minimum flash area also increased as you got closer to tornado touchdown, but at it was a much steeper trend. Next slide. We also looked at a frequency analysis. So specifically for flash extent density, we looked at the percent of tornadoes that have a flash extent density of 1, 2, and 3 per minute prior to tornado touchdown. So looking at the frequency of which these values were occurring and during every minute. And so we found that each plot for flash extent density of 1, 2, and 3 had an overall increase as you got closer to tornado touchdown. However, something interesting that we saw was that the smaller the flash extent density was, the higher these values were occurring, or the more these values were occurring throughout the data set for each minute. Next slide. Thank you. We did this same analysis for minimum flash area. And so for this one, we had split up minimum flash area between 1 and 100 kilometers squared, 101 and 200, and then 201 and 300. And so we just split up the data into these three categories. And overall, similar to flash extent density, we had found that there was an increase in this product as you got closer to tornado touchdown. And then it was similar between the first and second plot, whereas the 200 to 300 kilometer square plot had a little bit slightly increased, a slightly increased trend, or a more steep trend towards tornado touchdown. Next slide, please. And so the next piece of this analysis was looking at tornado cases. So we split it up by specific cases that we found interesting. And so for this, we looked at two tropical systems, one tornado from Hurricane Sally and two tornadoes from Tropical Storm Fred. And so we found that all of these tornadoes did have an increase in flash extent density as you got closer to tornado touchdown. However, there were a few interesting characteristics of these plots. So the first characteristic that we noticed, or we took notice to, was between minutes 8 and 18, the increase, or the increase in flash extent density got a little bit steeper. So there was definitely more of an increase in this specific area. Then between minutes 2 and 6, we had found that there was a decrease, or a rapid decline, in flash extent density right before it increased again before tornado touchdown. So those are just a couple of interesting attributes that we found with these plots. Next slide. But with the plots that had increasing, we did find some, tornadoes that necessarily showed the exact opposite. So this is just an example of a tornado that had a decrease in flash extent density as you got closer to tornado touchdown. Next slide. Thank you. And so looking at minimum flash area and doing the same analysis for minimum flash area, we looked at systems, Hurricane Sally and then Hurricane Elsa, two tornadoes from Sally and one from Elsa. And we found, similar to flash extent density, there was an increase in minimum flash area as you got closer to tornado touchdown. However, we also saw that this data was much higher in variability per minute, which led us to some conclusions surrounding that minimum flash area would not be a great product for forecasters to use in warning on these tropical tornadoes because of how high the variability was. Next slide. Thank you. We then looked at tornadoes and these products by tropical system. So the first system that we looked at was Hurricane Laura, which you can see the track. We looked at this hurricane because it tracked into the Western Gulf. But you can also see to the right image that the tornado locations that Hurricane Laura had dropped. Next slide. Thank you. So with Hurricane Laura, we found that flash extent density had a slight decrease towards tornado touchdown, whereas Hurricane Laura for minimum flash area had an increase in towards tornado touchdown. Next slide. We then looked at Hurricane Sally, and we looked at Hurricane Sally because it had a more eastern track into the Gulf. And then you can also see the locations of the tornadoes that Hurricane Sally produced. Next slide, please. Thank you. So Hurricane Sally, again, similar to Hurricane Laura, we found that the flash extent density as you got closer to tornado touchdown decreased, and that the minimum flash area increased as you got closer to tornado touchdown. Next slide. And then the last analysis that we did based on specific tropical cyclones was Hurricane Isaias, which we looked at this hurricane because it tracked up the East Coast. So we had a few different tornado tracks, or I apologize, hurricane tracks, which is how we deciphered which tropical systems to analyze. Next slide. So looking at the results of Hurricane Isaias, we found that similar to Laura and Sally, there was a decrease in flash extent density. But something interesting we saw was that the average flash extent density was significantly lower throughout the entire tropical system's tornadoes. And so we found that it was significantly lower compared to the hurricanes that tracked into the Gulf Coast. So Hurricane Laura and Sally had flash extent densities upwards of 3, whereas the average flash extent density for Hurricane Isaias was between 0 and 0.5, which is pretty interesting. Then looking at minimum flash area, opposite of what Laura and Sally showed, there was a decrease in minimum flash area as you got closer to tornado touchdown. Next slide. We then did a regional analysis. So first analyzing this by tornadoes that occurred in the northeast compared to tornadoes that occurred in the south. And we found that for tornadoes that occurred in the northeast, there was an increase towards in flash extent density as you got closer to touchdown. Whereas tornadoes that occurred in the south, there was a slight, if not any, trend downwards towards tornado touchdown for flash extent density, but it was extremely slight, if any. Next slide. Then we looked at another regional analysis of tornadoes that occurred in Gulf Coast states compared to tornadoes that occurred in East Coast states. And we found that for tornadoes that occurred in Gulf Coast states, there was a decrease in flash extent density as you got closer to touchdown, whereas for tornadoes that occurred in East Coast states, there was an increase. Next. Thank you. Continuing this theme of looking at flash extent density based off of the location that the tornado occurred, we did a latitudinal analysis. And for this analysis, we had split up the latitudes in 10-degree bins, and we had looked at 20 to 29 degrees, 30 to 39 degrees, and 40 to 49 degrees. And so looking at tornadoes that occurred in 20 to 29 degrees for the latitude, we found that there was a decrease in flash extent density as you got closer to touchdown. For those that occurred between 30 and 39 degrees, we found that there was really no trend at all. And then for tornadoes that occurred between 40 and 49 degrees, there was an increase. So it was really, we were really able to notice in these plots the shift from tornadoes that occurred in the south being a decreased trend, and then that shift as you move upward to being more of an increase in flash extent density towards tornado touchdown. Next slide, please. Thank you. So then we continued to do this with longitudinal analysis. So we looked at tornadoes that occur between 80 and 89 degrees, and then tornadoes that occur between 90 and 99 degrees. For those that occur between 80 and 89, there was a slight increase upwards for flash extent density, whereas tornadoes that occur between 90 and 99, there was a decrease in flash extent density as you got closer to tornado touchdown. Next slide. Thank you. We then continued our analysis and we shifted to looking at it by time of day of which these tornadoes were occurring. And so first we looked at flash extent density results for the daytime, and we had found that tornadoes that occurred during the day had an average flash extent density that increased towards tornado touchdown. Tornadoes that occurred during the nighttime had a decrease in flash extent density as you got closer to touchdown. Next slide. Then we went further with this analysis, and we had found that we had looked at, we had split up the daytime times, and we had looked at tornadoes that occurred in the morning and early afternoon, and then tornadoes that occurred in the afternoon and early evening. For tornadoes that occurred in the morning / early afternoon, there was a very, very slight increase. And then tornadoes that occurred in the afternoon / early evening, we found that there was a much steeper increase in flash extent density towards tornado touchdown. Next slide. So then lastly, the last piece of our results was we looked at flash extent density, like an analysis based off of tropical system status. So we looked at the time of which the tornado had occurred and compared that to which stage the tropical system was in at that moment. And so for tornadoes that had occurred during hurricane stage, we had found that there was a decrease in flash extent density as you got closer to touchdown. Whereas for tornadoes that occurred during other stages, such as potential tropical cyclone stage, tropical depression, or tropical storm stage, we found that there was an increase as you got closer to tornado, or in flash extent density as you got closer to tornado touchdown. You can move forward to the next slide. So in conclusion, we had found that flash extent density showed an overall gradual increase as time to tornado touchdown decreased. Minimum flash area showed an overall increase as time to tornado touchdown decreased. However, we found that this data was much higher in variability, which again led us to the conclusion that this product would not be a good product for forecasters to use in warning on these tropical tornadoes. Although flash extent density in Hurricane Laura, Sally, and Isaias all showed an overall increase, the hurricanes that tracked into the Gulf had a significantly higher overall flash extent density than the hurricanes that tracked up the East Coast. So Laura and Sally had very high average flash extent density values, whereas Hurricane Isaias did not, had very low compared to those two hurricanes. We then did a regional analysis that showed tornadoes that made touchdown in the South and Gulf Coast states had an overall decrease in flash extent density, whereas the Northeast and East Coast states had an overall decrease in flash extent density, whereas Northeast and East Coast states had an overall increase. Lastly, tornadoes, we did a time analysis, and tornadoes that took place during the nighttime showed an overall decrease in flash extent density, but those that took place during the daytime showed an overall increase. We further broke this up and found that both the tornadoes that occurred in the morning / early afternoon and tornadoes that occurred in the afternoon and early evening both showed an increase. However, those that occurred in the afternoon and early evening had a much steeper increase or a much more noticeable trend. Lastly, flash extent density in tornadoes that occurred during the hurricane status showed a decrease. However, tornadoes that occurred in other statuses, such as tropical storm, tropical depression, and potential tropical cyclone, showed a slight increase in flash extent density. Next slide, please. So for future work, we'd like to add additional years to the database. We found that 3 years is relatively small, so we'd like to add to that. We'd also like to compare ground-based lightning networks and then investigate corresponding radar imagery to identify where the GLM data added value. And then lastly, we'd like to identify storm environment differences in tornadoes that formed with / without a GLM signal. Next slide. So this project was funded through this project and internship were funded through the NOAA Ernest F. Hollings Undergraduate Scholarship Program. And I'd like to give a really big thank you to Frank Alzheimer, Chris Rohrbach, and the rest of the staff at the National Weather Service in Columbia, South Carolina for their mentorship and guidance throughout this entire internship and project. And with that, I'd be happy to take any questions.
Okay, thanks so much, Gabby. I do see some questions coming in, but I would just like to encourage everyone to stay on for the discussion that will follow. If you're in a forecast office or a regional headquarters, we specifically ask that if you have a question, please ask one in the chat. And when you do, if you're not signed in with your full name, please indicate your name when you ask your question. Just a couple of notes coming up a week from today, back at the normal time. So on Thursday, November 3rd, Michael Fulmer from the Ocean Prediction Center will be discussing RGB applications at OPC. So we encourage you to join us again next week, again at the normal time, 12 p.m. Eastern Time. If you have any questions about the Satellite Book Club or any questions about configuration of satellite products, please reach out to the Tower X team. You can do that by reaching out to Lee Byerly or Kashad Bowman. Again, if you have questions about this book club or any of your configuration of satellite products. Also, I believe we will be posting in the chat that there is a form for feedback. This is a Google form. So if you see that in the chat, go ahead and fill that out. And we encourage you to participate in that way as well. Looks like Lee just put it there in the chat. So we do have a couple of questions, and I will start with the first one. This is from Mark Demaria, and he is asking, were there any tropical cyclone cases with tornadoes, but without any lightning activity within the hour or so before tornado touchdown times?
Yeah, absolutely. There definitely were. There were actually a few of them. And so, yeah, there were a few tornadoes that did not have any lightning associated with them. And then there were also a few that if they did, it was within maybe a couple minutes sporadically throughout the 30 minutes that we looked at. But yes, the answer is yes.
Okay, great. The next question is from Bill Soberg. Did any of your conclusions surprise you? Did they make physical sense?
I would say that some of my conclusions with the minimum flash area in terms of their increase towards tropical tornado touchdown was surprising, but besides that, I really didn't find that much was surprising. I didn't really know a lot about the GLM and flash extent density and minimum flash area prior to coming into this internship. So it was a really great learning experience in that respect. But with that being said, I think, yes, through discussion with my mentors and such, that the minimum flash area probably was the most surprising. The rest was just very interesting to kind of learn about.
Okay, great. Next question is from Ben Schenkel, and he is asking if any hypotheses about why tornadoes at higher latitudes are associated with increases in lightning prior to tornado genesis. Could there be some relationship with extratropical transition in these cases?
I'm really unsure. My hope, my mentor is on this call too, and maybe he can jump in if I miss anything, but unfortunately I am a little unsure. It was definitely interesting to see that though, especially with those latitudinal trends that we saw with that shift from decreased flash extent density to an increase as you traveled further up north. But with that being said, it's a great question. I'm just unsure.
Yeah, I'm on if y'all can hear me. That's certainly, we believe it has to do, essentially you're more likely to have increased environmental shear as you're moving farther north. You're getting more interaction with mid-latitude type of systems. And so it's one of the reasons why one of the future works mentioned looking at the near storm environment for these different tornadoes is to take a look at that type of shear and try to identify for sure that is. But the hypothesis is it has to do with the shear. It obviously the extratropical transition is one person's extratropical transition is another person's continuing to have a tropical system, and it gets to be some hybrid information in there. But I essentially think that we're looking at a situation where the shear is increasing, which is likely helping to increase the potential for lightning with those particular storms. But it is an area for future work.
Thanks, Frank, for jumping in. And we also had Jose Garcia Rivera mention that he also suggested maybe trough interactions or the size of the tropical cyclone could be potential drivers as well. We don't have any more questions coming in. Just to give everyone a little bit more time, I'll ask a quick question and was curious if you foresee flash extent density or flash area being viable aids with warning on tropical tornadoes in the future?
Yeah, great question. Thank you. So for minimum flash area, we just with the higher variability and the sporadicness of the data, we found that, I definitely don't foresee this being an aid to forecasters in the future just because of how sporadic the data had acted. However, with flash extent density, I definitely think that there is potential in aiding forecasters. However, more research definitely needs to be done on this. This was just a 10-week, internship project that we had conducted. More research should be done on it in the future. And then also that would also allow for more years, because if we add more years to the archived GLM data, that would definitely be helpful in seeing if this is actually a viable product to use in forecasting. So overall, I think flash extent density has some potential.
Okay, thanks. Steve Corfidi is asking about flash extent density. Since it's kind of a proxy for mid-level lapse rates, is it possible that observed regional flash extent density characteristics would indicate that the northeastern US and daytime tornadoes possibly were more dominated by supercells located farther from the hurricane centers, where the lapse rates or the Cape might have been greater versus kind of the southern and nighttime cases?
Can you repeat that question one more time? I apologize.
Sure, it was kind of a long one. So just if you had any thoughts about those trends in flash extent density maybe being greater during the daytime in the northeastern US, just because the storm structure was more supercellular versus in the south or in the nighttime cases, that maybe the environment would have been a little less supportive of supercells.
Yeah, absolutely. So this was conversation amongst me and my mentors, and we had found that it was interesting with tornadoes that had occurred during the daytime compared to tornadoes that occurred during the evening or the nighttime, that we found that the flash extent density had increased with daytime, and we definitely found that it is, to do with like supercellular characteristics associated with it, and some of that heating that happens during the day. But overall, the second further analysis that we had done further, and that kind of backs up that claim in terms of, looking at tornadoes that occurred during the morning / early afternoon, and then the evening and or the afternoon and early evening, kind of supporting that, because we found that the flash extent density had definitely increased more so in the daytime, in the afternoon, as they continued. So yes.
Okay, great, that makes sense. Next question is from Ana Torres Vasquez, and she's asking, if you had to apply this to forecast operations tomorrow, what's one detail or takeaway that you would want forecasters to apply?
Oh, that's a fantastic question. One detail is definitely, if we're applying this research tomorrow, avoid minimum flash area. But in terms of flash extent density, it does vary depending on, the location and the time of day and such. So kind of just, if you had to implement it, say tomorrow, keeping in mind that the trends do shift depending on, what specifically you're looking at and where these tropical systems are making landfall.
Okay, and Walter Snell has a couple of questions. The first one was the direction of approach of the tropical cyclone, do you think that had any effect?
I think that yes, I think that there is some impact by that. We had studied the different tracks, looking at Sally, Laura, and Isaias, and we had studied, storms that tracked into different locations. So more western track, a more eastern track into the Gulf, and then up the East Coast. And we had found that there was differences, especially between those hurricanes that occurred in the East Coast or tracked into the East Coast in that direction, compared to hurricanes that had tracked up the Gulf Coast, and then compared to hurricanes that tracked up the East Coast. There was some pretty significant differences between those. My hope is that answers your question.
Yeah, and then his second question was just as you expand your area of study, both spatially and temporally, are you planning to consider adding Puerto Rico to your database?
That's a great question. No, we have not considered doing that, but that's definitely something to consider moving forward in our future work.
Okay, great. John Stopcotty asks, since your study was predicated on there being a tornado, do you plan to look at any null tropical cyclone events, places where there were increases in these trends without tornado genesis?
We hadn't thought to look at that. We haven't looked at that. But in the future, it definitely is something to consider and add to our future work.
Okay, and then last question I see coming in so far, Ben Schinkel asks, have you looked at the relationship between the distance of the tornadoes from the tropical cyclone center and the lightning trends leading up to tornado genesis?
That's a really interesting question, and no, we haven't looked at that, but that's definitely something to look at moving forward because that prompts very interesting. That's a very interesting question. So thank you for putting that in the chat.
Okay, well, that is all of the questions that I see so far, and I know you've had to answer a lot of them. So thank you again, Gabby, for presenting and for answering all of our questions. And I'm going to turn it back over to Brian for final remarks.
Okay, thanks, Jenny, and really appreciate you facilitating today's discussion, especially bringing that Topeka, Kansas tornado and lightning expertise. You've got a deep reservoir of that, so thanks very much. Also, thanks for you and Lee for your willingness to jump in as my laptop had some audio problems at the start. Gabby, intriguing study. Looking forward to seeing if the additional research that you recommended, we hope it's going on to confirm your findings on flash extent density trends in terms of tornadoes that hopefully has application even beyond the tropics. So great study, and thank you for it. Thanks also for the participants, these field reps, center reps, regional reps. These seminars are for you, so thanks for your participation, as well as the satellite programs and the Cooperative Institute partners and others here. As Jenny mentioned, please join us next week. We'll be back at our usual time, noon Eastern, that is, on Thursday, November 3rd, when Michael Fulmer will come talk to us about RGB applications at the Ocean Prediction Center. So with that, we'll wrap it up. Thanks very much, and have a great day.